Alright, now we're going to be moving on to conic section. So number one, just wants you to identify the conic section. So when you're identifying a conic section, look for the squared terms. So you'll see in this case, you'll see that there are two different squared terms. There's two things that tells you what's happening. First, the plus sign only happens if you have an ellipse or a circle. That's it. So everything else is currently ruled out. Next up, you'll see the coefficients are different. Because of that, this cannot be a circle because of these numbers being different, so this first one is an ellipse. You can just look for squared terms. So that's number one, is an ellipse. Number two, identify the conic. Now you'll see these are being subtracted. So if you're subtracting them, you either have a parabola or you have an hyperbola. But we can't have a parabola because I have two squared terms. A parabola would only have one squared term. So by default, this is a hyperbola. That's number two. And again, 1 and 2 we're just identifying the conic there. Number 3, identify the conic. Now you'll see that these coefficients are the same, and we have a plus sign in the middle, so this one's going to be a circle. Number 4, now you'll notice we only have one squared term. That's it. So if I was working this out, it'd be y equals ax minus h squared. Actually, it's going to be the other way around because the y is squared. So it'd be like x equals a y minus k squared plus h. It would have that form if I actually ended up solving it, which we'll do in some other examples, so we'll get to that. But that tells me it's a parabola. It'd be a sideways opening parabola, but it's a parabola because there's only one squared term. And if you only see one squared term, it has to be a parabola. It's the only one that does that. So that is number 4. So 1 through 4, again, all we're doing here is identifying, and then we start doing some work now, working these out, starting with number 5. So number 5 says what's the vertex and the directrix of this guy. So first off, I'm just going to go ahead and subtract that 2 over here. So I have x equals 8 and then y minus 3 squared minus 2. So we're going to start with the vertex. Now remember, in this case we have x equals a y minus k quantity squared plus h. Now if it's solved for x, this is our equation we're looking at. Now a couple things that we're able to do. First off, the vertex is going to be hk. So I have that. Now the directrix, we're going to need to find the focus in order to get that. So remember, the focus, we don't have an equation that literally gives us the focus. What we get is an equation that gives me the distance. So it's the distance from the vertex to the focus. And that equation is equal to 1 over 4a. So in this case, I'm going to go 1 over 4 times 8. So 1 over 32. So it's a really tiny, tiny number here. Okay, so that is, again, just the distance between the vertex and the focus. Now the directrix is just the opposite of that. So the directrix, we're going to use the distance negative 1 over 32. So again, let me show you a visual of this, kind of what it would look like. It's not going to be to scale, but I just want you to see what I'm talking about. So remember, our vertex in this case is at hk. Well, if I do that up here, my h value you'll see is negative 2. My k value, remember this value inside the parentheses is always opposite. Again, it's not just the h value that's always opposite, it's the number that's inside the parentheses that's opposite. So in this case, that's my vertical shift, because see how it's attached to the y and not the x. So that means instead of going down 3, I'm going up 3. So that's going to be positive 3. So that's your vertex. So that's taken care of. So I'm going to come over to my graph. I'm going to go to negative 2, positive 3. And again, this parabola, if you see the equation, I can tell because this a value is positive that this graph is going to open right. So this is a basic sketch of my graph. If I zoom in a little bit more here, I want to talk about the focus and the directrix. So this focus is going to be this point right here. Now, it is getting a little tight, but this distance, if you see this distance between the focus and the directrix, that distance is 1 over 32. It's really tiny. That's probably not even to scale because it's almost I'm going right 1. But just I want you to see the scale here. Now, there's a second point. This is the directrix. This is what we're looking for. And that's on the outside of the parabola. And again, the directrix is going to be a vertical line. But the distance from the vertex to the directrix, that distance right there is minus 1 over 32. It's the opposite direction. So if I want to figure out where the directrix is located, I know it's at x equals some number. Well, in order to find that number, I need to take my vertex, which in this case, as we stated, is at negative 2, 3, and I'm going to go left 1/32. So negative 2 minus 1 over 32, comma, 3. That's where you're, well, it's not, I don't even need the 3, I'm sorry. That's, it's a vertical line, it's not a point. So I just really just need to get that. Oh well, I messed that up. So yeah, so x equals negative 2. It's a vertical line, so I don't need to like write a point, an xy point. I just need to find x equals a number because it's a vertical line, and that's how you describe it. So if you're going to do that, writing it as a fraction, we just go ahead and do the math. Negative 2 over 1 minus 1 over 32. Get a common denominator, which is 32. So that would be negative 64 minus 1 over 32, which is negative 65 over 32. So your directrix, actually I'll keep that in blue here and make it darker. So your directrix is going to be right there. So and this problem says what is the vertex and the directrix. So my directrix is going to be x equals negative 65 divided by 32. And there's your directrix. That's kind of a quick sketch of your graph too, but those are the only two things we needed to find in this case. Alright, so that's number 5. Number 6, what are the vertices and the foci of the following ellipse? So it is telling you it's an ellipse, which is great. I will make these smaller for this problem. I don't want to run out of room with this. So this is an ellipse. What we need to do in order to find all that important information is we got to put it in standard form. To do that, we have to complete the square. So I'm going to put my x squared and my 4x together. We are going to complete the square on the x values and on the y values. So I'm going to have my 2y squared minus 12y plus blank as well. So in order to complete the square, for the y values, notice there is a GCF we're going to need to pull out. We need to pull out a 2 before we can complete the square. So I'm going to go 2, and that's y squared minus 6y plus blank. So now I can start solving. So with this first one, well, I'll copy this down. Why not? So it looks even. Okay. So as we're solving this, we're going to go ahead and do b over 2, which is 4 over 2, quantity squared. That's going to give me 2 squared, which is 4. So I'm going to add a 4 here. And because I added a 4 to the left-hand side, I'm going to add a 4 to the right-hand side. Okay, over here, on my y values, that's going to be 6 over 2, quantity squared, so 3 squared is 9. But remember, since this number is being multiplied by 2, I'm not adding 9 to the right-hand side, I'm actually adding 18. Because that 9 was being doubled automatically. So I'm going to add plus 18 to the other side. So that's going to be my right hand side. So now as we write this out, this is going to be x plus 2 quantity squared. If you do this right, we should have perfect squares, which I do, plus 2 times, and this is going to be y minus 3 quantity squared. On the right hand side, I have 18 plus 4 is 22. And lastly, to get this into standard form, this has to be equal to 1. So to do that, divide everything by 22. So this gives me x plus 2 squared over 22 plus y minus 3 squared. Now 2 over 22 simplifies, so that's just going to be 11. And there we go. Alright, so I have my standard form. So again, they are wanting the vertices and the foci. So that's basically, you just need to find your A, your B, and your C values for this. So obviously we have, in this case, our A squared, which is our bigger number. A squared is equal to 22, and B squared is equal to 11. So A is the square root of 22, and B is the square root of 11. Now C, for in this case an ellipse, if you remember the way I always remember this, the foci of an ellipse are inside the ellipse. So if you're ever trying to get confused with the formulas, there's a couple of them. Because this one's inside, we have to subtract our A and our B values, not add them like we have to do with hyperbola. Hyperbola, again, our foci are going to be farther away. They're not coming in, they're going out. So you have to add the A squared and the B squared. So anyway, the formula for this, before I write it down, again is C squared is going to, or C squared is going to be equal to A squared minus B squared. So in this case, that's going to be 22 minus 11. So in this case, that will actually just equal 11. So we get our C value is equal to the square root of 11. So we just want to see what we're looking for now that we have this. Again, it's the vertices and the foci. So if I come down here, I'm going to do a quick sketch of my graph. So if I'm sketching this, I'm going to start with my center. Now my center, if you look up above from when we put this in standard form, my center is going to be at -2, +3. So that's where I'm going to start my graph here. So I'm going to go left 2 and then up 3. So that's my center. And once you get that, to get the foci, you have to understand which direction this graph is opening. Well, my A value goes with my X value, which means this graph is more stretched left and right. It's going to look like this a little bit more. So my foci are going to be on the horizontal axes, because again, this is a horizontal ellipse. So that tells me that piece. So I know when I have my distance, my square root of 11, that distance is going left and right. So that means this distance right here is going to be C, and so is this one. So to get this point, the square root of 11 is a little bit bigger than 3, because the square root of 9 is 3. I'm just trying to get it somewhere close on my graph. So if I go right 1, 2, 3, that would put me at 1. So it's going to be a little bit before that. So actually, I think I put a pretty good spot there. So this point for my foci, again, it's a distance from -2. So it's going to be -2 plus the square root of 11, 3. And this other point out here is going to be -2 minus the square root of 11, 3. So those distances are going left and right. So that's going to be my foci. So I'll go ahead and label those off to the side here. My foci are at -2 plus or minus the square root of 11, comma 3. Next up are my vertices. And that's going to, let's make sure that's what they want. Yep, the vertices. So that's going to be my A value. So I'm going to go ahead and count left and right, in this case the square root of 22. I know the square root of 16 is 4 and the square root of 25 is 5. So it's a little bit less than 5. So I'm going to go off to the left. I don't care as I don't have it labeled. But I know, again, this distance right here is going to be my A value. And again, same thing if I go to the right. So this one I have labeled, so I'll try to be good here. So 1, 2, 3, 4, 5. If I went 5, I'd be at 3. So this is probably about right there. So again, I'm going right and left and right. In this case, the square root of 22. So negative square root of 22 and positive square root of 22 from my center. So Now if I'm labeling my center, I'll just do it over here. Again, it's -2, and I'm going to go plus or minus, in this case the square root of 22, comma 3. And that, the foci and the center of your ellipse. And again, if I did graph this, and I had the points out here, get my graph without finding B, looks something like that. Again, it's a real rough sketch of it. You can kind of see this would be your minor axis, this would be your major axis, and you'd have yourself an ellipse. Alright, so that is number 6. So moving on here, number 7, we want the center, the foci, and the asymptotes. So this one's already in standard form for you, so that's always good. So I already know the center is going to be at 1, -2. So that's good. With this one though, I do want to have a sketch of my graph. So I'm going to go ahead and get that going now. So I'm going to go right 1 down 2. Again, that's where your center is. Now, because again the x value is first on this one, again for a hyperbola, what tells you if it goes left or right is which term is first. The size of this number doesn't really matter. So if this is a 1 and that was a 4, it still opens right because the x is first. So with that being said, I'm going to go to this point 1 and -2, and I know my graph is going to look something like that. But in order to get that drawn, we need to draw our box. Remember, our box kind of comes into play once we know what our A, our B, and our C values are. And again, I want the foci and the asymptotes. So because I want the asymptotes, I need the box. So if you don't remember what the box is, here we go. First off, remember we got to find A, we got to find B, and we got to find C. C is the one we need the formula for. So in this case, it's C squared equals A squared plus B squared. Now we're adding because our foci is going to be a little bit farther away. It's not inside the conic section, it's outside the conic section. So that's how I always remember it. Okay. So first off, our A value again is always the distance we're traveling along that hyperbolic plane here, where it's going to open left and right. So our A value in this case is going to be the square root of 4, which is 2. And B is the square root of 1, which is 1. So C is going to be A squared plus B squared, so 4 plus 1, which is 5. And again, that's our C squared. So C is the square root of 5. So those are our distances. Now to draw my box, I can already find my foci, but I'll do that after I have my graph drawn. So to find the box, we're going to need that A and that B value. Remember I said that A value goes left and right because it's connected to the X. So I'm going to go right 2, draw like a little tick mark right there. Just going to get my box going. I'll go left 2, so it puts me at 0, and then -1, my next little tick box right there. And that's me going left and right. I'm going to go up and down 1, so my box is going to be very narrow, as you can see. So I'm only going up and down 1. And I'm going to make my box. And there's your box. And remember, we use this box to draw our vertical asymptotes. So I'll try to pick a light color, maybe this will work. So there's one vertical asymptote. And I'm going to draw my second vertical asymptote going through those other two diagonals. And this is what kind of sets the boundaries for your graph. Now the vertex is going to be right on the edge of that box. And this is opening left and right, so we approach those asymptotes. Okay, so I'm just about ready to go now. I got my graph, and again, I have the center, I want the foci and the asymptotes. So the foci, remember, are going to be these points right out here somewhere. Remember that distance is nothing more than C. So this distance is -C, and this distance right here is +C. So we start from the center, which is at 1, -2, and I'm going to go left and right, in this case the square root of 5. So my answer ends up being 1 plus or minus the square root of 5, comma 2. There's your foci. And then from there, we have to find the asymptotes. Well, the asymptotes are going to follow, let me write that down. They're going to follow this form. It's going to be y equals your slope. Now your slope, we use our box to find the slope. I go rise over run. So in this case, I'm going up 1, right 3. Again, well, that's actually 2, sorry. I go up 1, right 2. Now also you're going down as well, so your slope is going to be plus or minus 1/2. And then we're just going to go x minus h and then plus k. Use your center. Just write it basically in point slope form. For the most part is what we're doing. We're just using the center. Basically transformations. So I'm going to go right 1, so x minus 1. And then in this case, I'm going down 2, so minus 2. And those are the equations that represent your asymptotes. And that's the center, the foci, and the asymptotes of that hyperbola. So that's going to be number 7. Next up, we have number 8. And again, this says find the equation of the ellipse. So we have to find the equation. So in this case, I want to sketch this graph, and it's really just about finding your A's and your B's. Usually to get A and B, we're going to need, also we got to find our center. I guess I'll write the equation. Here's what we're looking at on number 8. So we have x minus h squared over a squared plus y minus k squared over b squared. Now remember, this works in this form if this ellipse is being stretched left and right. If it's being stretched vertically, then it just looks like this: y minus k squared over a squared plus x minus h squared over b squared. So we have to determine which one this is. And the way we do that, again, is we figure out if I was sketching a vertical ellipse, if it looks more like this, then my foci are on top of each other. Same as my vertices, they're on top of each other. But if this opens left and right, my vertices are left and right, and so are my foci. So we want to look and see how those foci are being labeled, and then we'll be able to determine which kind of graph we have here. So in this case, again, I'm going to sketch this graph. Once you have the sketch, it tells you so much. So we're going to go 1, 3. So 1, 1, 2, 3. So I have a foci here, and I have a foci at negative 3, 3. So two things this says. First off, this is not open vertically. You can tell the foci are to the left and to the right of each other. Second, I know the center. The center is right in between 1 and negative 3. So that's going to be right here at negative 1. So the center is at negative 1, 3. That's super important. We need that center. Okay, it's in between the foci. So again, a lot of cool information that just happened here. I know that where the center is. I now know my C value is 2. I mean, that's left 2 and right 2, but it's a distance, so it's 2 either way you look at it. So that's going to be 2. Let me go ahead and start labeling all this stuff. We're going to need our A, B, and C. So C I already know is 2. And remember, C is found by going C squared equals A squared minus B squared. So now we have our vertices, which are at 3, 3 and negative 5, 3. So that's a vertice, and then this is a vertice. So now again I can find my A value, because I know this distance is going from negative 1 to negative 5. So negative 1 to negative 5 is going to be 4. And again, it's 4, either way you look at it. For this distance, it's also 4. It just tells me I'm going right, but it's 4. So I'm going left and right 4. So that's what A is. So now to find B, that's the only other value I'll need here, I'm going to go C squared, which is 4, 2 squared, equals 16 minus B squared. So B squared equals 12. So B is the square root of 12. I don't really need to simplify that, because when you plug it into your standard form, it's written as B squared. So I'll just leave it as square root of 12. It's fine. So again, I'm now writing this equation. Go ahead and just bring it down here real quick. So let's see it. It is x minus h squared. Again, the center is at negative 1, 3, so that's going to be x plus 1 quantity squared over a squared. A squared is 16. And that's going to be plus y minus k squared. And again, your center is at negative 1, 3. So it's y minus 3 squared over b squared, which is 12. I don't know why I wrote y equals. I did that the whole problem. I'm sorry. But I fixed it. I finally did. I'm not re-recording this because of that. I did fix it. So, sorry. But there we go. That's going to be your equation. You can put the 1 at the end. It doesn't matter. And that's your equation for an ellipse in this scenario. And as you can see, that is conic sections. So only those sections we got are polynomials.